This is a very simple way to demonstrate a working electric motor. It uses an alkaline cell. I've got a D cell because we use the cell to wrap the wire around to get the right size loop of wire. You could use a AA cell, but you'd need something to wrap the wire around to be the right size. It needs to be an alkaline cell, not a rechargeable cell, because rechargeable cells have a very low internal resistance, and you do draw, it would make it draw quite a high current because you end up effectively short-circuiting for short amounts of time. The coil here is made from insulated electronics wire. It's single core wire. It needs to be single core wire because it gives you the stiffness for the wire to make its own supports. The supports on the sides are simply a 5 centimeter paperclip which has been stretched out, and I'll show you at the end of this video how to stretch it out to make the right shape to be the support. 2 bars of crocodile clips. This is a 1 pint plastic disposable cup, rubber band, and then at the top here we have a neodymium magnet. It does work with the flat rectangular Magnadur magnets that you get in schools, but I have a Neo here, which is a bit stronger. The Neo could be held on with a bit of blue tack. I've actually got on the inside of a cup one of these paper clips pushed up from underneath so that the magnet is holding from above and then being pulled down onto the paper clip underneath. You might just be able to see that here. If you can't, again, I'll show you that later. So all I'm going to do is touch the bottom and top of the cell, and we should see some movement. A little bit of movement there. Let's try it the other way around. There we go, and our motor is spinning. Now the one thing that this motor doesn't show is the action of the commutator. I'll explain what's different about this motor in a moment, but you can do a couple of things. So here we have it spinning, the bottom of the motor going away from us, the top coming towards. If I turn the power supply around the other way, the battery in this case, or the cell, then we should have it going the other way. There we go, that's spinning. And likewise, if you take the magnet off, flip it up the other way, you would also get a reverse in the change of direction. Need some Tipp-Ex. So the coil as it is, the way it naturally likes to fall, just because you're never going to make something perfectly symmetrical, it's slightly heavier on what turns out to be the bottom, and so that hangs at the bottom. That's the side when you want it to conduct electricity. When it's turned through 180 degrees, you don't want it to conduct electricity here, because you'd simply get this side of the coil pushed back the same way as the first side, and so you'd just be going between here and here, back and forth. So to do that, we take a bit of Tipp-Ex. I did this before I started videoing, and simply put a little bit of Tipp-Ex on the top here and here, so that when it sits in there, it only conducts this way up. Once it's turned the other way up, the Tipp-Ex is stopping it from conducting. Actually, marker pens work as well, although if you're doing this as a school experiment, I think the kids would probably understand more easily that you've got an insulator if you've actually got a layer of Tipp-Ex which can be seen. I don't know if you can see, that's quite white there compared with the silver underside. So this is simply a 1 meter length of wire which has been wrapped around here, and then to finish it off, I've just wrapped one end around a few times there and there, and then stripped the ends. So it does need to be insulated wire, because otherwise the current won't go around and around, it will just jump across the different layers and you won't get anything turning. The crocodile clips are just clipped onto the supports. and the supports, as you see, are held in place by the rubber band, and they are the paper clip, which has been opened up and bent to make a support here. It's a good idea to have some sandpaper so you can clean up any contacts. That includes this bit of the support, often needs to be cleaned up. The wire might sometimes need to be cleaned. Obviously you don't want to clean the side that you put the Tipp-Ex on. Perhaps even clean it before you put the Tipp-Ex on, if you're not sure it will work. And then again, the way that I held the Magnadur magnet in place was with this paper clip, which is on the inside. You can hold it in place with blue tack. If you have pupils who you think might want to walk off with one of these, what you could do is take my rubber band off here, take 2 plastic cups, put your magnet on top and put your other plastic cup over the top of that, and then you can staple your plastic cups together at the bottom so it kind of holds your magnet in place. Magnadur magnets are not quite as strong magnetic field, but it does work with those, and I have managed to get it working with those. A couple of safety things about these magnets. I've made a little separate video about safety with neodymium magnets if you use them, but please be very aware that they can cause injury. Make sure you've made a risk assessment before you do anything using these. Good luck, hope you enjoy it.